Alright guys, welcome to Calc with Colby. I think this is going to be the last video before the test. I don't see why it wouldn't be. So we're going to be going over not all of the review. We're going to be going over some questions, alright? Because, stuff like 6, you should know how to do 6. 10, I will go over 10. Determine whether Rule's theorem can apply to f on the closed interval. If Rule's theorem can be applied, find all values of c in the open interval a comma b such that blah 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 blah. So can it be applied or can it not? I mean, if you know whether or not it can be applied, it's pretty easy. It's the same as like finding the max or the min, right? So, well, actually, no, it's not. Is it? Wait. Such some value in there equals 0. And then you would find c. Yeah, no, that's easy, right? So what you're going to do is essentially just test if the equation is undefined or not within the interval. Okay, so here, it's fine. Here, it's fine, because there's no way that these can be undefined, right? Here, however, right, say x equals 1 here, the function's undefined, 1 is within the interval, doesn't work, so you don't need to do Rule's theorem there. And then for 12, that's fine, because sign is never undefined, right? So we're going to move on. 13, that's the mean value theorem. You know what, I'll do the mean value theorem. Okay, so the mean value theorem for 13, f prime of c equals f of b minus f of a all over b minus a. All right, and then f of x equals x to the power of 2 over 3, and we are on the interval 1, 8. Ignore my terrible brackets. All right, so here, I mean, it's pretty simple. Take the derivative of this, so we'll just do y prime because I'm lazy. That equals 2/3. It's 2 over 3 x to the power of negative 1/3, because you do chain rule, that becomes, yeah, you guys know how to do chain rule. I'm not going to bore you. So, yeah, we'll just, the power of 1/3. Okay. So this equals this, right? Pretty simple. So we'll put that over here, 3x to the power of 1/3 equals f of b. So we plug in 8, take out our trusty calc, 8 to the power of 2 over 3. We get 4. 4, that's a bit far over. 4 minus a, that's just going to be 1, over 8 minus 1. So that's going to get us 3 over 7. Now we multiply this over, right? So 2 equals 9 x to the power of 1/3 over 7. Multiply both sides by 7, we get 14. And I guess divide both sides by 9, so, well, we'll write this out. So 14 equals 9x to the power of 1/3 over 9 over 9. And that should get us, well, equals 14/9. And then we take the cubed root of this, which will be, I don't know, whatever the cubed root of 14 over 9 is, equals x. Or c, I guess, in this case, right? So we'll plug the John in. What is the, I guess it's going to be 14 over 9 to the power of 1/3. Is what I would say if I was a fool, you see. It's not actually the cubed root of that. It's that cubed because that is the cubed root. So to cancel that out, it'd have to be cubed, which means that's actually cubed. And I knew that because I'm a smart person. That's a big number. That's a more manageable number. So x equals 3.76. We'll flip to the back of the book, make sure that's actually a thing. If not, we cry ourselves to sleep. Let's see. Let me flip the page, please. 13. Well, that says 3/7, which... Huh? Am I tweaking? Huh? Find all values of c in the open interval such that blah, blah, blah. Am I tweaking? Why is it doing f prime of that? Okay, well, that's c equals this. But... what? So it's saying c equals 2,744 over 723, which is what I got. But I don't get why it's plugging that back into the derivative. Oh. Oh, nope, that's just proving it. Okay, so you would plug that back into here, and then see, oh, does that equal 3/7? It does. That's what it's saying. Okay, had me tweaking for a second there. But this is, that's all you'll really need to give. All right, so bring this up, moving back through this. Intervals on which that's increasing or decreasing, don't need that. 34. Find the critical numbers of f, if any. Find the open intervals. Apply the first derivative test to identify all relative extrema. Use a graphing, that doesn't matter. Okay, we can skip through that. 45. The function st describes the motion of a particle along a line. Find the velocity function of the particle at any... You guys can't really see that. At any time. Huh. Oh, what's crazy is that isn't in the review, so I'm just not going to do it. 45. Using the second derivative test. I'm going to be completely honest, I don't remember the second derivative test at all. Let's flip back a bit. What was that? Limits at infinity, skip back too far. Increasing and decreasing functions in the first derivative test. Yeah, skip ahead a bit. Okay, so what is the second derivative test? If f double prime of c is greater than 0, wait. If f prime of c equals 0, and the second derivative of f exists, if f double prime of c is greater than 0, then there's a relative minimum at c comma f of c. And if f double prime is less than 0, then it's a relative maximum. But if f double prime of c equals... Okay. You know, sure, we'll do it. All right. So y equals 2x squared 1 minus x squared. So we'll go to the second derivative of that, I suppose. Or no, we'll take the first derivative first. So 2x squared d2 is going to be... that plus 1 minus x squared times 4x. Okay. Is that right? Is it times 4x? Yeah, it is. Okay. Getting all that in. Oh, wait, yeah, I need to but parentheses around all of it. Okay. So that's negative 4x cubed plus 4x minus 4x cubed. Bang, bang. Y prime equals that. And here, well, where does x equal 0? When does this equal 0? When x equals 0. So it means our c equals 0 there. So take the second derivative of that. Y double prime equals 4. So we plug that in. Hey, it's increasing! I think that's what it was. Was it not? Or it might have been opposite. Okay, but hold on. Shush up the comments. Okay. If f double prime of c is greater than 0, then f has a relative minimum. Well, it is greater than 0, so we plug it into our original equation. We get 0. So there is a minimum at 0, 0. Now the thing is that this is completely useless if we set up our intervals and whatnot, which is what we typically do, because why would we go through all of this effort when we just have this and we can do negative infinity, comma 0, and then we can find out our intervals, and that actually just gives us more information. It seems completely worthless, but whatever. We'll check the back of the book. What was that, 45? Yeah. All right, let's make sure that that was correct. 45. Well, I missed out on the relative minima, or maxima, which is so strange. The relative minimum is at 0, 0. But there's a relative maximum in here. And I somehow completely missed it. What the heck am I oh, yeah, those don't cancel. So it wouldn't be that. It would be equals negative 8x cubed plus 4x. And then you take the derivative of that and you get like negative 24x squared plus 4. Where does this equal... Or no, wait, where does this equal 0? At 0, and then solve that for 0, and you get like, I don't know. Well, actually, if you take out an x, negative 8x squared plus 4, you subtract that over, divided by negative 8, you get like 4 over 8, which is like 1/2. The square root of 1/2 is 1 over root 2. Which I guess could be root 2 over 2 if you rationalize the denominator. And is that what the other one was? Yeah, it was. All right, well, root 2 over 2. Plug that into this TS. I mean, if you plug in a 0, it's still positive 4, so that's fine. Plug that in. It's like a number lower than 0, so that becomes a max. So max at root 2 over 2, and since I don't really care to plug it back in, we're just going to look at the book. That says 1/2. All right, so don't make that dumb mistake on the test. That's going to be bad. All right, moving on. Next would be 49. Sketch the graph of the function having the given characteristics. Actually, could be pretty important, so I think we'll do this. Thing is that's a lot of characteristics, so we're just gonna say we're just gonna graph this TS. All right, so okay. So there's a 0 here and a 0 here, because f of 0 equals f of 6 equals 0. All right. F prime of 3 equals f prime of 5 equals 0, which means there's a critical number at x equals 3 and x equals 5. So here it changes. Well, actually, we don't even know that. Like, we don't know. All right, sorry. As I was saying, there's critical numbers here and here. Well, we don't know if they're zeros, but f prime of x is greater than 0 for when x is less than 3. So it's increasing until here. F prime of x is less than 0 for when x is greater than 5. So we're decreasing past this point. Well, we don't even know where that is, but we're increasing up to here. Oh, hold on, wait, I missed one. F prime of x is greater than 0 for when x is between 3 and 5. So we are still increasing. Okay, then I'll shorten this down just a bit. So we'll like put it here or something. So we're increasing, and then once we hit 5, so like here, then we just do that. Okay. Probably. Something like that. All right, then f double prime of x is less than 0 for when x is less than 3 or greater than 4. So we're actually going to write down some of this information. So between hold on. Okay, actually, since we're not given any information, we'll just move that over to there. So when x is less than 3, so between negative infinity and 3, and between 4 and infinity, I think, yeah. F double prime is less than 0. So f double prime is less than 0. That means we're concave down in both of these. So, okay. So, you know what? We're going to hold off on sketching the graph for a while. All we know is we're just going to list out our information. So negative infinity, comma, 3, 3, comma, 5, and then 5, comma, infinity. It's getting in the way of the graph, but whatever. Here it's decreasing, here it's increasing, and here it's increasing, which means we have a max here. We don't know what that is, but, you know, it's fine. F double prime of x is greater than 0 for when x is between 3 and 4. So, well, probably should have left some space there. But it's all right. So 4, comma, infinity, c, that's not a c, cd. And then between 3 and 4, we're concave up. All right. So with all of this, make it to here. We're increasing, but we're concave down. So probably something like this. Like, well, I mean, we don't know how much we're increasing, so probably like that maybe. And then we switch to concave up, increasing until 5. So then we become like that. And it wasn't really a great model of that, but we like do a bit of that. And then we're concave down again until 5, which is about here, and then we start decreasing. I know this is going into my information, but whatever. So increasing, concavity shifts to concave up, concavity shifts to concave down, stays concave down, and then we're increasing up until 5. I know the graph is wonky, just don't worry about it. And we start decreasing again. All right, very nice. Now, what's 49? We just did 49. 57. Find the limit if it exists. I'm gonna go with undefined personally, because this is, as x approaches infinity, x squared over 1 minus 8x squared. So that would be like infinity over infinity. So I'm thinking this is gonna be a no. I think it's gonna be a not quite, not a no bueno. Let's see, 57. Never mind, it's negative 1 over 8, actually. Sure. I don't know how. Like, actually how, but am I just, like, being dumb? You know, let's figure this out. So the limit as x goes towards infinity is x squared over 1 minus 8x squared. So we'll replace these with infinity, right? So infinity over 1 minus 8 infinity. Well, infinity squared, actually. And that's infinity squared. Now the thing is I'm just not quite sure how this is meant to. All right. Either I'm just being dumb or some math is not working out here. I guess we need to like get that out of the denominator. So I guess, okay. Here, let's actually think about this. If we need to get this out of the denominator, then we'll multiply it by the denominator by 1 over x squared, right? Or maybe like top and bottom by 1 over x squared. I think that's, yeah, that's something we can do, 1 over x squared. So that becomes 1 over x squared minus 8. And that's 1 over infinity, which is 0, because infinity equals something over 0. So 1 over infinity, you flip that, that's 0 over something. So obviously that becomes 0, which makes sense. Now that's negative 1/8. Okay. Yeah, that checks out. Okay, noted. Next, 66. Use a graphing utility to graph the function and identify any horizontal asymptotes. That seems kind of boring. We don't really need to do that. Especially for 66, considering there literally are... Are there? No, there are. It's just at y equals 5. Which is really easy. Alright. Analyze and sketch a graph of the function. Here we go. This is the fun stuff. And it's a radical. Okay. So, 71. X equals root 16 minus x squared. 16 minus x squared. Are you guys ready for this? This is the important stuff, okay? The rest of this is, like, kind of important, you know, like, you should probably know it. But that's what's on the quiz or on the test tomorrow. So, lock in, okay? This is the time to focus. So, equals y. No asymptotes, easy enough. What's the x-intercept gonna be? So that's when y equals 0, right? When does y equal 0? When x equals 0 and when x equals, like, 4. So 0, 0, 4, 0. All right, that's going to be your y-i's. Incorrect. That's going to be your x-intercepts. I always get them mixed up. It's not hard to catch your mistake when you make it, though, because, well, if you were to plot these points, this is not touching the y-axis. Crazy, I know. All right, and then when you set x equal to 0, you get 0. Crazy, I know. Okay. That's all we can get from that, so take the derivative of that 1d2, so x 1/2 16 minus x squared negative 1/2 minus 2x plus root 16 minus x squared times 1. Okay. Now this, right, you guys should know at this point. Come on, this is like level 1 math kind of stuff. This is pretty simple. All you really need to do is just take out one of these Johns, all right? Because we have one of them in each term. It's simple as that, right? So 16 minus x, that's a weird thing. Okay, x squared to the power of negative 1/2 times, all right, well, those will cancel. So we have negative x squared plus, and so this is essentially to the power of 1/2 minus a negative 1/2, because you're taking out a negative 1/2, which means it becomes 16 minus x squared. Okay, pretty simple, right? That's gonna go to the bottom, whatever. Oh, actually, let me label this y prime. So y prime, y prime. Okay. That's gonna become negative 2x squared plus 16 over 16 minus x squared, and square root that. All right. Now, set it equal to 0, right? Well, y prime equals that, set it equal to 0, because set it equal to 0. Come on, this is math, basic math 101. So does this work out? Yeah, it does. It's going to be subtract 16 over negative 2x squared equals negative 16. Divided by negative 2 gets us x squared equals 8, so it's just x equals root. Well, I kind of ran out of space there, but, you know, we'll also solve the denominator as well. So when does root 16 minus x squared equal 0? Well, you square both sides to get rid of the root, and 0 squared is... It's 0. Crazy, I know. 16 minus x squared equals 0, and then over, take the square root of it, x equals 4, comma, root 8. Is what I would say if I was a fool, because we have to do plus and minus for both of those, right? So plus or minus root 8, and plus or minus 4. Now, we set up our intervals, all right? So between, I'm going to think for a second, actually. When is this undefined? Right? Like when would this function be undefined? It's going to be undefined whenever we have a negative under here, which is going to be when x is greater than 4 or less than negative 4. So our x has to be between negative 4 and 4, right? So all of these should fall under there, but it's an important thing to remember, right? So this interval will be negative 4 comma well, that's already included there, so that's fine. And then that's going to be negative root 8, yes. Negative root 8, comma, root 8, root 8, comma, 4. Okay. Now, we'll plug that back into our derivative. So, negative 3, I guess. So negative 2, negative 3 to the power of 2 plus 16. All of that is going to be me. Where can I put the calc so you guys can see it, but it's not blocking? I guess I can just move this up. All right. Put that there. Then that is over root 16 minus negative 3 to the power of 2. Bang, bang, bang. It's negative, right? And then we'll plug in 0, which we can just do in our brains because we're smart. Positive over positive. Positive. That we can't just plug in 0, and I'm too lazy to use my brain for this, so we'll just plug in a regular 3. It's not impossible to figure this out without a calc, but it does make it easier. It's negative, I think. Yep, it's negative. So decreasing, increasing, and decreasing. All right. This means we have since going from decreasing to increasing, we have a min, increasing to decreasing, that's a max. That's going to be at negative root 8, comma, we'll figure that out in a minute, and that's going to be at root 8, comma, and we'll figure that out now. Plug both of those back into here. That's going to get us, that's actually not that hard to figure out. Negative root 8 squared is it's 8. So that's going to be 4. And then I'd have to multiply it by root 8. All right, hold on. Let me just... root 8. Actually, it's negative root 8. Where's the negative? There we go. And then I'll make sure the calculator won't do anything funny. Times root 16 minus negative root 8 to the power of 2. It's negative 8. Plug that in there, and then plug in a positive. It's probably just going to be regular 8. Crazy. Okay. So we have that. Take the second derivative now. So that's here. y double prime equals bot d top root 16 minus x squared. D top is negative 4x minus top negative 2x squared plus 16 times the derivative of the bottom. This might... I think I can just copy it from up there. The only issue is it's gonna take like a lot of space to do. X squared. Okay, well, this isn't being very space conscious right now. Just, okay, just imagine the rest of it is here. All right. And I don't want to do that. But I also don't want to rewrite the whole thing. All right, you know what? We're going to do something dumb and just move it down to the next line, which is really stupid and should not be done ever. Top debot, so 1/2 16 minus x squared negative 1/2 times negative 2x. All right. Those cancel. Remember, it's all over bot. I'm not gonna forget this time. 16 minus x squared. All right, now we can take out a negative 1/2. So we'll move to, I don't want to move to over there. That's where all my information is. We'll just hope it like really crunches down. Okay, so 16 minus x squared to the power of negative 1/2 times negative, yes. That becomes just 16 minus x squared, so that's going to be negative 64x plus 4x cubed. Okay. If that's taken out, then it's just a negative x that we're multiplying that by. So minus 2x cubed minus 16x. Distribute that through. Oh, and it's still all over 16 minus x squared. BT dubs. Okay, so y double prime. This is going to have to be our last thing because I'm really running out of space here. Distribute that through. That becomes a negative 2x cubed, which means this becomes 2x cubed. That becomes positive 16, which means this becomes negative 48x. All right. We'll put the 2x cubed first. 2x cubed minus 48x, except we can take out an x from that actually, so we're gonna do even more. 2x times x squared minus 24 all over 16 minus x squared, power of 3/2. Set that equal to 0. So we have an, I'll just move it all the way over here. X equals 0, comma, plus or minus root 24, comma, plus or minus 4. So we have negative 4, comma, okay, hold on. I want to think about this for a second. So that's greater than 4. So we actually don't need this. That can't be in the interval. So it's just 0 and then plus or minus 4. All right. Comma 0, 0, comma 4. Test for concavity. Let's plug that into here. We'll plug in like a -2. So negative times a... All right, Calc, help me out. All right, so plugging this into our Calc, I'm just gonna do this out over here. Okay, so 2 times, we'll do, I guess, -1 times -1 to the power of 2 minus 24 over 16 minus -1 to the power of 2 to the power of 3/2, which is positive, and then just plugging in a regular one will get us a negative. So this is CU and this is CD. Now, with all of our information here, this is everything we could possibly need. I mean, not really. I mean, we have a POI at, that's not how you make the at symbol, at 0, 0. Because, well, you would plug in your critical number here, which is 0, or your point of interest here at 0, and then you'd plug that back into your original equation, but we already did it here with our x and y intercept. So this means, all right, let's make the graph. It's gonna have to be on a different page, which kind of sucks. There's gonna be a lot of flipping, unless I were to like repeat all of the information down, but I don't particularly want to do that. So make our graph here. It's really wide for like no reason. We'll do, I'm just looking at this. We'll do intervals of 1. All right, so 1, 2, 3, 4, 1, 2, 3, 4. And then vertically we'll do, goes up to 8, so we might as well do 2s. So 2, 4, 6. Thank you, pencil, for breaking on me. We appreciate you. 8, 2, 4, 6, 8. And then we'll label this, make sure that they know that's a 2, and that's a -1. That's a -2, that's a 4, that's a -4, and that's a 2. All right, so starting off, we have, you guys really aren't going to be able to see this that well. I'm sorry. We have an x-intercept at 0, 0, and at 4, 0. So here and here, we have an x-intercept. Y-intercept at 0, 0. We have a minimum at -√8, comma -8. -√8 is like, it's going to be like here, because it's above -√4, but it's less than -√9, right? Because that would equal 2, that would equal, it'd equal -2, and that would equal -3. So we'll put it like here, and then that goes down to like here. All right, that is a minimum. And then we have a maximum like here, go up to 8, so right here we have a maximum. Okay. Then we have a point of inflection at 0, 0. So it's concave up until here, and then for the rest it's concave down. Now, for decreasing from -4, so we'll, I don't know where it, let's starts per se. It could be something like all the way up there, but, well, no, it can't be. But I don't know if it starts like at -4, if it's like all the way. I guess we can plug in the point and see what works. Well, I'm realizing that the x-intercept should have been ±4, so we'll put 1 there. That was my bad. So we're concave up, so concave up decreasing looks like that, concave up increasing looks like that. I mean, it could be like there more so. Then we switch to concave down, start decreasing there, and then stop. Okay. So this should be roughly the graph of the function. Time to take a look in the book. All right. Looking at the review exercises for 71. Right here. That's what our graph should look like. That's what my graph looks like. Their graph is a bit more scrunched than mine because they did it by intervals of 2 on the x-axis as well. But it is pretty much the exact same. So I'm quite happy with that. Now, I lost my place because I flipped over to there. I think we'll do one that is a polynomial, and then I think we'll call it a day. How's that sound, guys? So, yeah, this actually isn't in the homework, but we'll just do 70, because that's a polynomial, and we have to graph that. So, y equals x to the power of 4 minus 2x squared plus 6. All right, now I'm going to try and do this without my calculator. Probably not going to be possible, unfortunately. We know the y-intercept will be 0, 6, because we plug in 0 for x here. 0 minus 0 plus 6 equals 6. The x-intercepts are a bit more tricky to figure out because we'd have to solve for x here. Like that's when y equals 0, and that's a bit more tricky to solve for. I don't really want to do all of that, so we'll skip it for now. Hopefully that doesn't come back to bite us. And there's no asymptotes or anything, so we'll move on to differentiating it. So y prime equals, the nice thing about this is that they're really simple. Like it's just going to be minus 4x. Like it's just that, right? Set that equal to 0. You can solve for that pretty easily. It's going to be x 4x squared minus 4 equals 0. We get x equals 0, comma, add 4 over, that's going to be divided by 4, square root that, x equals the square root of plus or minus 1, which is just plus or minus 1. All right, set up our intervals, so that's wrong. Negative infinity, comma, -1, -1, comma, 0, 0, comma, 1, 1, comma, infinity. Quite a few intervals, shouldn't be too hard. Plugging in a -2 for this one, so -8 minus wait, we'll plug it in over here actually, because that's a negative times 16 minus 4 is positive. Negative times positive, that's going to be negative. Plug in a negative, like, I don't know, 1/2 here, I guess. That's going to be less than 4. So that's going to be negative times a negative. So that should be positive. So decreasing, increasing. Plug in a 1/2 here. Positive times a negative. It's going to be negative, which is decreasing. And then plug in a 2 here. Positive times a positive. increasing. First try. Let's go. All right. Put that in, put that in, put that in. So decreasing to increasing, that's a min. This is a max. This is a min. All right. At -1, comma, plug that back in. 1 minus 2 plus 6 is like, I don't know, a large number probably. It's 5. This is at 0, comma 6. We already established that. And that is 1 will be 1 minus 2 plus 6, 1 comma 5. All right. All right, we have all of our information from our first derivative. Now for the second derivative, y double prime equals 12x squared minus 4. All right, that equals 0. Add 4 to both sides, so plus 4 plus 4. That's going to be x squared equals 1/3. So x equals plus or minus 1 over root 3. Or root 3 over 3, if you really want to be fancy. Okay, yeah, that checks out. All right, then set up our intervals. Making sure the math actually does check out. Yeah, it does. All right, so -∞, comma, -1 over root 3, 1 over root 3, comma, infinity, is what I would say if I was a fool, because that's -1 over root 3, 1 over root 3, 1 over root 3, comma, infinity. We'll plug in like a -1 for this. 12 times -1 squared, which is 1. 12 minus 4, that's positive. We can plug in a 0 for this. Oh no, it's -4. What do we do? This is terrible. Guys, how do we do this? Guys, how do we do 0 minus 4? I'm so lost right now. It's minus. All right, CU, CD, and then we plug in a 1 for this. It's 12 minus 4, positive CU. All right. This is all of our information. It's not. So we have, I mean, it doesn't really matter. Possible POIs. They are POIs. POI at -1 over root 3, comma, comma, 1 over root 3, comma, and I mean, we'll plug it back in because like it, you know, is like kind of important. So it's not quite as simple as -1, 0, and 1. That's gonna be -1 over root 3. Oh no, wait. To the power of 4 minus 2, -1 over root 3, to the power of 2, plus 6. I'm missing an end parenthesis here. It's at 6.8. You know, I want to actually find out. I'll do that once I'm done with this. Okay, so take out the negatives from all of these. It's that, and then that's 5.4. What is 1 over root 3? Oh, thank you. It's 3 over root 3 over 3. I'm smart. All right, so we'll change that to 5.58. because I like decimals. So 0.58, 0.58, or 0.6, or whatever. All right, now that's all of our information. Which I'm realizing is really interesting that we have a point of interest at 6.8 when we have a maximum at 0.6. This is really interesting. So how did I do that? I figured out how. There we go. Well, that's still the same thing, but what about the negative there and the negative there? All right, so they're both at 5.4. Okay. Oh, that makes things more better. Okay. Now, plotting their Johns out. We'll do intervals of 2. Okay, thank you, pencil. I didn't want that bit of lead anyways. It's fine. Intervals of 2, -2, comma, negative... There's no comma there. I don't know why I said that. 6, and that's the max it'll go to. So we'll just go out one more, just to be safe, because I like being safe. And then we'll do the same for y. 1, 2, 3. Okay. Really don't appreciate my lead just breaking, like, constantly. Like, maybe that means I'm applying too much pressure to the pencil, but I don't know. Okay. So, y-intercept up here. Perfect. X-intercepts? I do not know. I don't know how I would know either. I mean, like, I guess... I mean, it's not impossible to figure out. It's just I'm really lazy and don't want to. So instead, we're just gonna kind of guess a little bit. Okay. Minimum at -1, 5. So, okay. So minimum here and here. And then a maximum here, and then another minimum here. Point of inflection, like here and here. Okay, so we're going from... Oh, this is interesting. So we are concave up, decreasing, which means we're like... What the heck? Okay. Concave up, decreasing is like that. So we're like barely inching downwards, and then we like... I guess there are no x-intercepts then, since it seems like it's just oscillating between that. I mean, I can know. Unless it's... I guess it doesn't have to be like that. It could be like we... And then that's still concave up. Then we switch to concave down increasing. Like so. And then there, concave down decreasing, concave up decreasing, concave up increasing. That seems about right. I couldn't check because the back of the book doesn't have evens for this, but this seems like a reasonable graph for that function. And you know what? We actually can check because we have a calc. So get rid of that. X to the power of 4 minus 2x to the power of 2 plus 6. Bang. I didn't need that. Okay. Head into graph, and let's see. I don't actually know if you guys can see that. Okay. That's what the calc gave me. That's what I had. It's the same graph. So I'm happy with that. Are you guys happy with that? I'm very happy with this. I think this was a very productive video. If you guys enjoyed, like, subscribe, hit the bell, notifications, all that good stuff. I just did my outro on my actual channel. I am very tired. I've done like just calc for the past 2 hours. This has been terrible. Okay, so quick brief summary. Basically, everything aside from the last 2 problems I did will not be on the test tomorrow. So this and this could be on the test tomorrow. Everything above that, no, it won't be. And it may be on the test Friday. However, a lot of it is pretty easy. Mean value theorem, I think she's just going to give us the thing for. So it really shouldn't be too difficult of a test. You guys got this. I believe in you. Good luck and peace.